A particle of mass m and charge q is released from rest in a uniform field of magnitude E. The uniform field is created between two parallel plates of charge densities plus sigma minus sigma respectively. The particle accelerates towards the other plate a distance d apart. Determine the speed at which it strikes the opposite plate. So here, as you can see, the upper plate is positively charged and lower plate is negatively charged, and E naught is the field in between the plates, which is uniform. Okay, and particle of mass m and charge q is released from rest in a uniform field of magnitude E. The uniform field is created between two parallel plates of charge densities plus sigma and minus sigma, and the plates are at a distance d apart. Okay, d is the separation between the plates. So if we release a particle from this position, suppose from one of the plates, so with what speed it should strike the upper plate? So we can see that its motion is continuously accelerated because of this electric force. So how much is the magnitude of this electric force? Q E naught is the electric force acting on this particle, and this remains constant magnitude wise as well as direction wise. And because of this force, when particle starts from rest and travels a distance d, then work done by this electric force is equal to force into displacement in the direction of force, which is d in this case. So this is the work done by electric force. So according to work energy theorem, we know that total work done on any of the system is equal to change in its kinetic energy. So here the only work is by the electric force. So that must be equal to the change in kinetic energy. So let us assume it strikes the other plate with a speed v. Suppose v is the speed with which it strikes the other plate. Then we can write this relation as q E naught d is equal to k2. K2 is half m v square. V is the speed with which it strikes the other plate, minus k1. K1 is obviously 0 because the particle was initially at rest when it was released. Okay, so you can see that speed with which it strikes the other plate is equal to under root of 2 q E naught into d divided by m. So option B will be the correct option to this question.